Na plus and Cl minus ions. The decomposition of sodium chloride into Na plus and Cl minus ion is called as electrolysis. Two commonly used methods of electrolysis involve molten sodium chloride and aqueous sodium chloride, which give different products. As we have discussed, electrolysis is the passage of a direct electric current through an ionic substance that is either molten or dissolved in a suitable solvent. This results in chemical reactions at the electrodes and the separation of materials. Two commonly used methods of electrolysis involve molten sodium chloride and aqueous sodium chloride. You might think that both methods would give you the same products, but this is not the case. Let us go through each of the method to understand the different process. First, about electrolysis of molten sodium chloride. If sodium chloride is melted above 801 degree centigrade, then two electrodes are inserted into the melt and an electric current is passed through the molten salt. Then chemical reactions takes place at the electrodes. Electrolysis cell for molten sodium chloride. A commercial electrolysis cell for the production of metallic sodium and chlorine gas from molten sodium chloride. Liquid sodium floats to the top of the melt above the cathode and is drained off into a storage tank. Chlorine gas bubbles out of the melt above the anode. Sodium ions migrate to the cathode, whereas electrons enter to the melt and are reduced to sodium metal. In the form of equation, Na plus by taking electron from cathode converts to sodium. Chloride ions migrate to the other way towards the anode. They give up their electrons to the anode and are oxidized to chlorine gas. That means Cl minus ions moves towards anode where they lose their extra electron and converts to Cl. The overall reaction is the breakdown of sodium chloride into its elements, that is 2 moles of sodium chloride converts to 2 moles of sodium plus chlorine gas. Here the electrolysis of molten sodium chloride is explained in the form of diagram. Here the molten sodium chloride is highlighted with yellow color. When the current is passed through this battery to the electrolyte, then decomposition takes place. That means sodium chloride converts to Na plus and Cl minus. After that, the positively charged Na plus ions moves towards negatively charged electrode, that is cathode, where they will get electron and converts to sodium. Now the negatively charged Cl minus ions moves towards the positively charged anode, where they lose their extra electron